Did you know that a quantum computer could solve problems in minutes that would take a traditional computer millions of years? Yes, you heard that right. Welcome to the fascinating world of quantum computing, a realm where bits transform into qubits, and where the conventional rules of computing give way to the strange yet wonderful principles of quantum physics. Quantum computing is not just an upgrade of classical computing, it's a game changer. While classical computers use bits, ones and zeros to process information, quantum computers use quantum bits or qubits. Unlike bits, qubits can be both 1 and 0 at the same time, thanks to a quantum quirk called superposition. This means a quantum computer can process a vast number of possibilities all at once, exponentially increasing its processing power. But that's not all. Quantum computers also leverage another quantum phenomenon known as entanglement. When qubits become entangled, the state of one qubit instantly affects the state of another, no matter the distance between them. This interconnectedness allows quantum computers to process information in a highly sophisticated and complex manner, far beyond the capabilities of classical computers. Imagine a maze. A classical computer would try every path one after the other until it finds the exit. But a quantum computer, it can explore all paths at once. The implications are staggering. Problems that seem insurmountable today, from cracking complex codes to simulating the behavior of molecules for drug discovery, could potentially be solved in the blink of an eye. However, let's not get too carried away. Quantum computing is still in its infancy, and there are many technical hurdles to overcome before we see quantum computers in our homes or offices. But the potential is undeniable. The quantum revolution is on the horizon, promising to redefine our understanding of computing and unlock solutions to problems that today seem beyond our reach. This immense processing power is what sets quantum computing apart from the classical computers we use today. In the next scene, we'll delve deeper into the heart of quantum computing. Join us as we journey into the future of technology. At the heart of quantum computing lies the quantum bit, or qubit, a unit of information that defies the binary code we all know. Dive a little deeper into the quantum world and you'll encounter the qubit. It's like the bit in classical computing, but with a twist. In classical computing, a bit is the smallest unit of information, and it can be either 0 or 1. You can think of it as a light switch that's either on or off. But in the quantum world, things are a bit more peculiar. The qubit, short for quantum bit, also holds information. But unlike its classical counterpart, a qubit doesn't have to decide between 0 and 1. It can be both at the same time. How is this possible, you ask? Well, it all comes down to a phenomenon called superposition. Superposition is a fundamental principle of quantum mechanics, and it's a bit like being in two places at once. Imagine you're at home and at the beach simultaneously. Sounds impossible, right? But in the quantum world, it's business as usual. A qubit in a superposition state can be both 0 and 1 simultaneously, not unlike being at home and the beach at the same time. Now, we shouldn't think of this as the qubit being unsure or indecisive. It's not that it can't make up its mind. Rather, it's more like the qubit is exploring all possibilities at once. It's this ability to be in multiple states, to hold multiple pieces of information simultaneously, that gives qubits, and by extension quantum computers, their immense potential. But, like all good things, there's a catch. The moment we try to measure a qubit, it collapses out of its superposition state and becomes either 0 or 1, just like a classical bit. It's a bit like Schrodinger's cat, both alive and dead, until you open the box to check, at which point it's either one or the other. It's the qubit's ability to exist in multiple states at once that gives quantum computers their superior processing power. This is the heart of quantum computing, a world where the classical rules of computing are both upheld and defied. Quantum entanglement, a phenomenon so bizarre Einstein himself called it spooky action at a distance. Let's dive into the eerie realm of quantum physics. Imagine two particles that, no matter the distance between them, are forever linked. Change the state of one and the other responds instantaneously, as if they were one and the same despite being miles or even galaxies apart. This is the uncanny concept of quantum entanglement. Quantum entanglement isn't just a product of the wild imaginations of science fiction writers. It's a real, observable phenomenon. and it's one of the cornerstones of quantum computing. In a classical computer, information is processed using bits, which can be in one of two states, 0 or 1. But in a quantum computer, information is processed using quantum bits or qubits, which can be in both states at the same time, thanks to another quantum peculiarity, superposition. When qubits become entangled, the information they carry becomes linked. A change to one qubit will instantly affect its entangled partner no matter how far apart they are. This allows quantum computers to process huge amounts of data simultaneously, offering unprecedented computational power. But quantum entanglement is not just about speed. It's also about creating a new level of connectivity. Imagine a network of quantum computers, all entangled, sharing information instantaneously. This could revolutionize fields like cryptography, where secure communication is paramount, or artificial intelligence, where processing vast amounts of data quickly is key. However, harnessing the power of quantum entanglement is no easy feat. The delicate state of entanglement can be easily disturbed or lost, a challenge known as decoherence. Scientists are still grappling with ways to maintain and control this fragile state in practical, real-world quantum computing systems. So, while quantum entanglement may seem more like magic than science, it's very much a part of the quantum computing revolution. It's a concept that takes us beyond our everyday understanding of the world into a realm where the laws of physics as we know them seem to be turned on their head. Quantum entanglement, despite its spookiness, is one more piece of the quantum computing puzzle. In 2019, Google claimed quantum supremacy, announcing that their quantum computer performed a task in 200 seconds that would take a supercomputer 10,000 years. Yes, you heard it right, 10,000 years. This remarkable achievement marked a new era in computing, one that could revolutionize every aspect of our lives and society. But what exactly is quantum supremacy? And why should we care about it? Well, quantum supremacy is the point at which quantum computers outperform traditional computers in a specific task. It's like a milestone in a marathon, signifying that quantum computers are not just theoretical, but practical and powerful. Google's claim was a demonstration of this power. But why does this matter? Imagine a world where diseases are cured even before they manifest, where climate change is tackled with unprecedented precision, and where complex mathematical problems are solved in the blink of an eye. This is the world quantum computing could unlock. In the field of cryptography, quantum computers could crack codes and encryption that would take traditional computers millennia to decipher. This could potentially enhance the security of our digital communications, but also pose new challenges for maintaining privacy. In drug discovery, quantum computers could significantly shorten the time it takes to model and test new drugs. This could lead to breakthroughs in medicine that were previously thought impossible. In climate science, quantum computers could simulate and predict complex climate patterns with a level of accuracy never seen before. This could give us the tools to combat climate change more effectively and sustainably. In short, the applications of quantum computing are vast and far-reaching. They hold the promise of solving some of our greatest challenges and unlocking new opportunities. However, it's important to remember that we are just at the beginning of this journey. There are still many hurdles to overcome and many questions to answer. Quantum supremacy isn't just a lofty goal, it's a reality, and it's only the beginning. The dawn of the quantum era is here, and it's set to redefine the future of computing. Quantum computing holds a promising future, but it's not without its challenges. As with any revolutionary technology, it comes with its own set of hurdles that need to be overcome. Firstly, let's consider the issue of error correction. Traditional computers have well-established methods for detecting and correcting errors. However, quantum systems are much more delicate, and errors can easily creep in due to factors like environmental noise, making error correction a significant challenge. Another challenge is stability or coherence. Quantum states are incredibly fragile. They can exist for just a fraction of a second before they collapse, making it tough to perform computations in that brief window. Researchers are consistently working to extend this time frame, and while progress is being made, there's still a long way to go. Despite these challenges, the field of quantum computing is not standing still. It's a vibrant area of research with scientists and engineers across the globe working tirelessly to overcome these obstacles. And the potential rewards? They are enormous. Imagine the pharmaceutical industry, where quantum computing could drastically speed up the process of drug discovery. Or the field of logistics, where the immense computational power of quantum computers could optimize complex systems like never before. And let's not forget about cryptography, where quantum computers could both threaten existing encryption methods and offer new, unbreakable codes. The potential impact of quantum computing is vast and varied. It promises to revolutionize industries, boost scientific research, and provide solutions to some of the world's most complex problems. But it's important to remember that the road to this quantum future won't be easy. It will require continued investment, collaboration, and above all, perseverance. The quantum future may be fraught with challenges, but the potential benefits make it a journey worth embarking on. As we stand on the brink of this new era, it's clear that the quantum revolution is not just a possibility, but an inevitability.